Okay, so hello everyone. Welcome to the third live section of this course. I'm Gitanjali. I'm a PMRF scholar from IIT Delhi, and the A for this course, which is Foundation of Classical Electrodynamics. So, uh, let me. So, as I said before, we'll start from the problems that is related to week three, and we'll try to solve few problems that is related to the concept and is suggested by you. By some of you, I will try to cover few problems from Griffith also, which will help you to understand the concept better. So, um, can anyone please confirm whether my voice is audible or not? I think it should be audible, but let me know. After that, we'll start solving few problems. So in week three, so my voice is audible, right? Okay. So in week three, we basically we learned about how we can convert from one coordinate system to the other coordinate system. So we basically learned about what are the generalized coordinate system, how what are the general formula to relate one coordinate system to the other coordinate system, like from Cartesian to cylindrical or from cylindrical to Cartesian and vice versa. So, and besides that, we'll also look at one function that is useful for EMT. So this function is the Dirac delta function, and we look through uh, different properties of Dirac delta function in what and how it can behave and how it can behave on a function and derivative and etc. So let me start solving few problems. So this problem is from Griffith. So I think one of the student asked about solving question number 31 from Griffith. So let me uh, start solving it. So this question is based on calculating the volume integral of a function over a tetrahedron which has corners at 0, 0, 0, 1, 0, 0, 0, 1, 0 and 0, 0, 1. So let us plot how the tetrahedron looks like. So it is four corners. One is at 0, 0, 1. So let me plot it first. So we have X, Y, and Z. One corner is at 1, 0, 0, then 0, 0, 0. Other it is 1, 0, 0. This is 0, 0, 1. So we need to, the question asked to find out what is the volume integral of this function, which is z square over this tetrahedron. So for this volume integral in Cartesian coordinate, this is nothing but t dv over the volume v, and this will be z square dx dy dz. So to solve the volume integral, you need to know what are the limits are, what are the limit of x and y and z, and how these different coordinates are related to each other. So for this, we need to find out what is the equation of one of the plane. Um, and if we recall, I think some of you must have known how to find out what is the equation of a plane given you have coordinates or corners of this plane. So for this, we use the concept that the normal vector to this plane is perpendicular to any vector lying on this plane. Let's say this plane is PQ. So this any vector lying on this plane is perpendicular to the normal vector. So this is 0. So this will have the normal vector will have xyz component, and the PQ also have xyz component. So using this, you can easily find out equation of a plane is nothing but ax minus x0 b y minus y0 plus c z minus z0 equal to 0. So ABC, these are the xyz component of the normal vector, and x0, y0, z0. This is one of the corner point of this tetrahedron. So finding the normal vector, if you recall, it's easy. If you know two vectors for this plane, let's say this is x, z, y. So if you know two vectors, then you of this plane, then you can easily calculate what will be the normal vector of this plane. So normal vector is n cap is nothing but xy cross xz by mod of xy mod of xz. So xy, this is x is 100 minus, sorry, this coordinate should be 010. 010. So this will be minus I cap plus j cap. Similarly, you have the other vector xz, which should be 001 minus 100. So this will be minus j cap plus k cap. So unit vector for this plane is minus I cap plus j cap cross minus j cap plus k cap, all divided by root 2. So this will be I cap. Just solve it, take the cross product, you will find this will be I plus j plus k by 2. Sorry, this will be root 3, right? No, root 2. Okay. Then what you have, so you can find out ABC is half, half, half. So now you just use a x minus x0 plus b y minus y0 plus c, z minus z0 is 0. ABC are equal, so this will give x minus x0 plus y minus y0 plus z minus z0 is 0. So you can take any corner if you want. So this will give same equation. So let us take corner 1 0 0. So this will give x minus 1 plus y minus 0. So we have the relation of x is y minus y plus z. Okay. So you got the formula, the relation of the coordinates. Now you just put it in the volume integral to find out what will be the volume integration. So t dv, it is z squared dx dy dz, uh, z squared. So what will be the limit for dx? So the minimum limit is 0 and maximum is 1 minus y plus z. Similarly for dy, you will have a limit. So let us first solve dx first, then we'll see it will be dz. So this will give z square integration 1 minus y plus z dy dz. And what will be the limit for y now? So minimum value is 0, maximum value will be 1 minus y. Right? Okay, so I think I will put a value for okay. So this will give z squared and this limit will give, one will be give y. Okay, so this should be 1 minus z, right? So we are taking limit on y. So this should be 1 minus y. So one is y and this is y square by 2 and other one is z y. So limits are from 0 to 1 minus z dz. So just solve it. You will get z square. So just put the limits. You will get 1 minus z square minus. Overall, you will get 1 minus z square by 2. Okay. And the limit for z is from 0 to 1. So z varies from 0 to 1. So this equation is easy to solve. You will get 1 by 60 for this tetrahedron. So volume integral will we will get 1 by 60. So is this clear? So you just need to find out what is the relation of x, y, z. Then just putting the limit for x, y, and z, you can get what is the volume integration. If yes, then let us go to question number. So in last live session, we haven't solved four, I think three more questions. So let us solve those first. Then we'll move to our next uh, problems that is related to week three. Okay. So please try to solve it first. So the question is to find out what is the Laplacian of the following equation. You have a function t x plus y square plus xz plus 3. So for this function, you need to find out what is the Laplacian of this function t. So please solve it and let me know the answer. This is easy because these are all based on the Cartesian coordinate. Try to solve it first, then I will go through. So you need to find out del square t. Yes, so this will come out as 2. Okay, so just use del square t by dou x square plus del square t by dou y square plus del square t by dou z square. So double derivative of x, this will give 0. This will also give 0. So this will give 0. Double derivative of y square for dou square by dou y square, it will give 2. And double derivative of z, this is constant, this will be 0 and this will give 0. So answer will be 2. And okay, so this is for first part. Let me know the answer for the second part where t is e to power x plus sin y cos 2z. Okay, the one of you have already solved it, but I think there is yes. Okay, you have one query, I think, Someswar. So I have unmuted you, so let me know your
Yes.
query.
I'm unable to write anything in my chat. How to enable that?
You are unable to write it in the chat.
Yes.
I think it's allowed for everyone. Only the camera and the mic is visible from my side.
Okay. Okay, madam. Please continue. And at the end of your session, I will have some queries. So I will ask those.
Okay, okay. Okay, for this one, uh, it's easy. Double derivative of x will give e to power x, and double derivative of sin y, it will give cos y and sin y. So minus sin y will be there, minus sin y cos 2z, and the double derivative of cos 2z will give 4 uh, sin y cos 2z. So this will be e to power x minus 5 sin y cos 2z. Okay. Okay, so let us move to our next problem. So this is to calculate what is the divergence of. Okay, so the picture is missing, I think. So you need to find out the divergence of a function v in a volume, which is missing here. So let me draw it. So you have a volume like. So this is the volume, and the intercept z x. This is y. And this intercept is 1 for y. This is 2 for z. The maximum is 2. This is also 2. So for this function, which is given v, which is 2xy xk plus y squared zq y cap plus x square z minus 2y z cap. Find the divergence of this function for this volume. So this will take a few minutes. So let me solve it. Instead of telling you to solve, let me solve it. So what you can do for this? So you can see this is a it has a triangular part as well as it has a rectangular part also. So what you can do, you can divide the whole volume into two parts. One is for one is a cube, which is so two volumes. One is a cube from which is y ranging from 0 to 1, which is so I am talking about this volume. This is a cube. And the second volume, it will have y, which is varies from 1 to 2. So finding out for the cube, it's easy, right? So you can easily just put the formula for the volume. So divergence of v dv. And dv for this cube is dx, dy, dz. So v is given. So divergence of v. So if you recall the lecture, to find out the divergence, what we need, or for Cartesian, it's easy. You don't have to remember the formulas. So you just need dou vx by dou x plus dou vy by dou y plus dou vz by dou z. So this will give, just check the answer, whatever I'm writing, check it. And if it's not matching, then let me know. So this will give 2y I cap or x. Sorry, there will be no unit vector. So this will be 2y and this will give 2y z cube. And the third will give dou v by dou z. This will give x square. So you have 2y 1 plus z cube plus x square. This is divergence of the function v. Now the divergence of v dv, this will be over the volume v is triple integration 2y 1 plus z cube plus x square dx dy dz. And the limit for x, if you see, this x will vary from 0 to 2, y will vary from 0 to 1, and z is from 0 to 2. So you will have 0 to 2 for x, 0 to 1 for y, 0 to 2 for z, 2y, 1 plus z cube plus x square dx dy dz. So just solve it one by one. Let us solve z first, then you can solve y, then x. So if you solve z, this will give 2y, 1 will give z, z cube will give z4 by 4 plus x square, dz will give x square z. And the limit is 0 to 2 dx dy. So if you put the value of z, you will get this will give 12y and this will give 2x square dy dx. Now take the integration for dy. This will give 12y will give 6y square plus 2x square y. And the limit is 0 to 1 dx. So this will give 0 to 2, 6 plus 2x square dx by putting the limits. And eventually this will give 6x plus 2 by 3 x cube. Limit is from 0 to 2, which will give 52 by 3. So this is for the first volume, which is a cube. For the second one, you can see it's a triangle. It's an extended triangle in y direction. Or divergence theorem. I didn't get your doubts. So do you want what is divergence theorem, or can you elaborate your doubts? Okay, in the meantime, let me solve it for the triangular part. For this triangular part, y has range from 1 to 2 and z is from 0 to 2 and x is from 0 to 2. So for this, what you need to do, you just need to find out how these coordinates are related to each other, how y is related to x or y is related to z. So for this, we have x here, z here, and y. So let us see how y and z are related. And you can easily calculate it, just use the 2-point formula for this. You can see this, the relation is z is 4 minus 2. Let me know if you are able to find it. If it is okay for everyone, then I'm going to skip it. If not, then I will show you the steps. So for this plane, we have z equal to 4 minus 2y. So now we know the limit for z. So let us see what will be the divergence. So this will give triple integration. You have 2y z cube plus 1 plus x square dy dx dz. And the z limit, it should be from 0 to 4 minus 2y. And y limit 1 to 2. X limit is from 0 to 2. So just put the limits, you will get, this will give 176 by 15. So that means you have divergence of V dV is 52 by 3 plus 176 by 15. This will come around 436 by 50. You can follow these steps also, or what you can do, if you are not able to find the volume integration, what you can do, you can use the divergence theorem. Like divergence of V dV is equal to the surface integration. So that process you can also follow, and they both will give the same answer. Okay. So do you have any doubt in this problem? It's 1 minus 2y equal to z, right? No, it's just check it once. So you are saying z should be 1 minus 2y. So if you put z equal to 0 here, then this will give y equal to half, which is not true. When z equal to 0, y should be 1. So what if you have confusion in this, what you can do, so you have a line here. This is, let's say it's giving y1, z1. This is y2, z2, right? And the equation of the line, if you remember, this is y minus y1 equal to, sorry, let me write it. This is the line y1, z1, y2, z2. So you have z minus z1 is y minus y1, z2 minus z1, y2 minus y. Intercept is 1. Here the intercept is 2 here. Here also this is 2, not 1. I think that may be the reason that you are not getting it. And the x-intercept is also 2 here. Y2, Z2 is, this is 0, this is 2, and Y1, Z1 is, this is 2, sorry, Y2 is 1, right? And this is Y1, Z1 is 0. Okay, I think the length of the intercept is 1. Yeah, the magnitude is 1. I think you are this. So remember that we are not starting from origin. Okay. So this will you are, I think you are putting this equation y is mx plus c, right? And you are saying this intercept is 1, that is why the m should be 1. But we are starting from 1 here. So this will be the more general, sorry, this will be z, or z is minus mx plus c. So it's better to use this formulation because we'll get wrong value if you start from, if it is not origin, then you will get wrong value. Okay, let me move to our next problem. This one is easy. You just need to check what is the whether the gradient theorem is satisfied here, not satisfied here or not. Okay. So for this, what you need to do, remember the gradient theorem is A to B, divergence of T dl should be Tb minus T. So if you have a function T, which gradient we know, then if you take the integration along a path, then this will give Tb minus T. And we have two functions. One is z equal to y square, sorry, two path, and one is z equal to y cube. And we have a function t is 3x z square minus y square z. So let me know what will be the divergence of t. What is the value we will get? This is all in Cartesian coordinates, so you will get, you can easily get what will be the divergence, sorry, gradient of t. Let me know the answer. So what will be divergence of t? This will be dou by dou x. Okay, so I'm just writing the answer. This will give 3z square x cap plus minus 2yz y cap plus 6xz y square z. This is the divergence of t, and the dl will be, this is in the yz plane, so dl will be dy y cap plus dz z cap. It's the combination of both dy and dz with x equal to 0. So let us see the first path, which is z equal to y square. We have path 1, z equal to y square. So for this, we can write dz is 2y dy. So to simplify the integration further, you can write it this way. So divergence of t dl, this will give minus 2y, z is y square dy minus y square 2y dy. So which is nothing but 4 yq dy. Now when you take the integration from a to b means the limit for y is 0 to 1. So this will give 0 to 1 4 yq dy. This will give minus 1. And tb minus ta is, so b point is this point. It's given 0 0 0 0 1 1. So b point is 0 1 1. So t 0 1 1 minus t 0 0 0, which will give minus 1. So the gradient theorem is valid for this path z equal to y square. Similarly, you can do it for z equal to y cube. Okay, so I'm skipping this. Just verify whether it is valid for this path also. Okay, so this is all for tutorial 2. Now let us start our uh, week 3 contents. So first we'll start from the Dirac delta function. So in first question, you have to evaluate what will be the Dirac delta of integration of this function with delta x minus 3 dx. So can anyone please let me know what will be the answer for this? You can take it as f of x, and this is delta x minus 3. This will give a 20. Good. So if you recall the lecture, this is nothing but 226 f of 3 delta x minus 3 dx and f of 3, and you have to see also whether the point where the Dirac delta function is non-zero, whether it is lying in the limit or not. Okay, so first check whether this is in the limit. If it is in the limit, then it will give a non-zero value. If not, it will give a zero value. For this case, the non-zero value will occur at x equal to 3. And this will be, and the 3 is within the limit 2 to 6. So that is why this integration will be f of 3, and which will give 3 is square minus 2 3 minus 1. So 20. Okay, so this is for the first part. Let me know what will be the answer for the second part. For second part, you have 0 to 5 cos x delta x minus pi dx. So these are easy. You just need to put the value for Dirac delta function. Yes, you are correct. This will give minus 1. So f of x is cos x here, and the non-zero value will occur at pi, which is within the limit of 0 to 5. So this will be cos pi, which is minus 1. Okay. For the C part, this is 0 to 3 x cube delta x plus 1 dx. For this, f of x is x cube here, and the non-zero value will occur at minus 1, which is not within the limit of 0 to 3. So that is why this will give a value of 0. Okay, so last d is minus infinity to infinity ln x plus 3 delta x plus 2 dx. For this one, f of x is non-zero at x, sorry, delta is non-zero at x minus 2, which is within the limit. And if put ln minus 2 plus 3, this will give ln 1, which is 0. Okay, so this covers the Dirac delta for one of the kind. Now let us see for the next Dirac delta function. In first part, you have minus 2 to 2, 2x plus 3 delta 3x dx. What will be the value for this? So recall delta kx is 1 by mod k delta x. One. Yes, it's correct. So this is 1 by mod of k is mod of 3 delta x dx 2x plus 3. And the Dirac delta is non-zero at x equal to 0, which is within the limit. So that is why this will pick up the value at 0. So this will give 1. For the b part, let me write b is 0 to 2 x cube plus 3x plus 2 delta 1 minus x dx. Okay, so 6 is correct. This is similar to what we have seen in the second problem. Delta is non-zero at x equal to 1 and 1 is within the limit of 0 to 2. So the function, integration will be the function value at x equal to 1. So this will give 6. Okay, so for C part, minus 1 to 1, 9x squared delta 3x plus 1 dx. Try to recalculate. For this one, what we have 3x plus 1, right? So what you can do it here, you can take out a 3 common, x plus 1 by 3 dx. So it's similar to like kx. So delta kx will give 1 by k, which is 1 by 3, delta x plus 1 by 3 dx. So the value will be non-zero value minus 1 by 3, and minus 1 by 3 is within the limit of minus 1 to 1. So that is why this will give 9 by 3 x squared minus 1 by 3 squared. So 1 by 3. Yes. Okay, so for the last option, we have, let me do it here, d minus infinity to a delta x minus b dx. What will be the answer? So for this one, what you have, it's like you don't know whether b is within the range of minus infinity to a or not. So this will give 0, or it will give a value of, so 0 value will get it when the b value it is greater than the limit, greater than the maximum limit. So when b is greater than a, and this will, sorry, this is for the 0 value when b is greater than a, and when b is within the limit we'll get a value of 1. So b is less than a. Okay. Okay, so this is about the some of the integration involving the Dirac delta function. Now let us see the problems based on divergence theorem or Stokes theorem, or the conservative field. Okay. For this problem, the question asks about check whether the divergence theorem for the function v r square cos theta r cap plus r square cos phi theta cap minus r square cos theta sin phi phi. So we have to check whether this divergence theorem for this function is valid in this following volume. So the volume is 1 octant of the sphere of radius r. So let me go through the steps because it will take 2 minutes to solve it. So divergence theorem, if you recall it, this relates the volume integration with the surface integration for a function f. Volume integration is equal to the surface integration surrounding this volume f dx. And the divergence of f, this is a spherical coordinate, so you need to use the generalized formula. The generalized formula is 1 by hi hj hk dou by dou ui. So in the previous live section, I think I have done it in a different way. So instead of hi sjhk, I have taken FGH. So don't take that formulation, because if you take it, then you may get confused going through the lecture material, then other problems. Okay, so try to stick to only one formulation. This formulation, these are equivalent. So if you remember one of these, then it's easy to correlate in other. Okay. So for divergence, we have 1 by HI Sj Hk, which is the scaling factor, dou by dou Uy Hk Fi. And for spherical coordinate, if you remember, Hi is 1, Sj is r, and Hk is r sine theta. So these are the scaling factor. So now we can, so divergence of F is divergence of alpha plus divergence of theta plus divergence of phi. So this is 1 by r square sine theta dou by dou r. Ui is r, and Hi Sj Sk will give r square sine theta, and f of r we have r square cos theta. R square cos theta. For dou by dou theta, we need to take Hi and Hk. So this will be r sine theta, and f of theta is r square cos phi. So try to solve these kind of problems, because if you skip it, then it's hard to find. If you may not be able to find what will be the uh, simplest question. Like if the question asks about what will be the line integration or what will be the volume integration, then you won't be able to find it. So try to solve this kind of problem, because this will thoroughly help you to understand the concept, or how you can use it, the different length element in different cases. Okay. Okay. So for phi, we need, this is r, and f of phi is minus r square cos theta sine phi. R square cos theta sine phi. Okay, so now just solve it. I'm just writing the final answer that we'll get. So this will give 4r cos theta. You can see it here also for dou r. This sine theta will cancel, and r to r 4 will give 3r, 4r cube. So that is why 4r cos theta is there. And this will cancel with theta, will cancel with phi. So you have 4r cos theta. Now it's easy to find out the volume integration, divergence of F dV, and because it's a sphere, the volume would be r square sine theta d theta d phi. So it's r square sine theta d theta d phi. But the limit is different here, because it's a octant of a sphere. So that is why r will have 0 to r. Theta, it will be from 0 to pi by 2, and phi will be 0 to pi by 2. Or r cos theta, or r cube cos theta sin theta d phi. So RQ, it will give R to R 4 by 4. So R to R 4 and 2 pi will give pi by 2. So let us R to R 4 by 4 will cancel. And we have theta integration from 0 to pi by 2. Sin theta, cos theta, d theta. So this will be pi R to R 4 by 4. Just check the final answer. So this is for the LHS side. So this is the volume integration of this function. Now for the surface integration. So you need to integrate it over the outer surface or the surface which is enclosing this volume V. Okay. So we have the sphere like this. So what are the total surface we have? Can anyone tell? So we have a total of four surface. One is the curved one. So the curved one will give a surface. So this dA, the area of this curved surface is dA1. And for this curved surface, the radius will be constant. So the area element will be r square sine theta d theta d phi in the direction r k, and r is constant here. So that means it will be r square sine theta d theta d phi r k. What is the other surface we have? The bottom one, the bottom plane one. So for this surface, if you see this surface, here the phi is changing from 0 to pi by 2 and r is constant and theta is, sorry, r is changing and theta is constant. So that means for this surface dA2, we have r sine theta d phi dr in the direction theta, where theta is pi by 2. So this will give r d phi dr theta k. So is this clear? So the next surface we have is the left one. For this left surface, what is changing? Phi is constant, is at 0. Theta, it is changing from 0 to pi by 2, and r is changing from 0 to r. So the area element for this one, it should be in the direction of the parameter which is constant, which is phi. So it will be in the phi direction. In phi direction, we have r d theta dr minus phi. So phi is in this direction. That is why we have taken minus phi for this surface. The last surface we have is the backside. We have a flat surface. For this surface also, what is constant here? The phi is constant, which is a value of pi by 2. Theta is changing from 0 to pi by 2, and r is changing from 0 to r. So the area element for this is dA4. It is similar to r d theta dr, but the unit vector is in the positive direction and phi is pi by 2. So r d theta dr phi cap. Okay. So this is all about finding the area element of different surface. Once you find out what is the area element, then finding the uh, surface integration is easy. So for this, we have f dA. This would be f dA1 plus f dA2 plus f dA3 plus f dA4. Let us see this one first. So for dA1, it is in the arcade direction. So that means f in the function f, so let us take this. We need to take the arcade. So f dot dA1, it should give r square cos theta and the area element is r square sin theta d theta d phi. D phi is from 0 to pi by 2. So this will give r square 4. This will give and we have cos theta sin theta d theta. Sorry, r square is constant, right? So there is no integration on r. So this is r to the 4, 0 to pi by 2, which will give pi r to the 4 by 4. So this is for first surface. For the second one, which is the bottom, dA2, this is in the direction of theta cap. So this will give f dot dA r square cos phi r d phi dr, and r is from 0 to capital R, phi is from 0 to pi by 2. Just calculate it, it will give r to the 4 by 4. For the third one, dA3, this is in the phi direction, the phi cap direction. R square cos theta sin phi r d theta dr, where phi is 0. So if you put phi is 0, this will be 0. So the total integration is same. For the third one, third integration. So the last one is f dA4, which is also in the phi direction, but the phi is pi by 2 here. So this is r square cos theta sin pi by 2 will give a value of 1 r d theta dr. So there will be minus sign here because this is minus. Okay, so this limit integration will give, I think, minus r to the 4 by 4. Just check this, check once. Okay. So the area integration will give r12 4 by 4 and minus r12 4 by 4 will cancel. So the area integration, the surface integration is f dot d is pi r2 4 by 4, which is also equal to what we have seen by taking the volume integration. So that means the divergence theorem is valid inside this volume and while taking the function f. Okay. So do you have any query in this problem? Because it was quite a long one. Let me know if you have any query, whether while integration or finding the area element. If it is clear to everyone, then let us move to our next problem. So this is based on the Dirac delta function. So try to calculate first, then I will let you know the answer. Integration is r square plus r dot a plus a square delta q r minus a dv. A is a fixed vector with magnitude a and the integration is over all the space. Anyone? It's a three-dimensional Dirac delta function. Try to see where, in which case, in which point the Dirac delta function is non-zero value. dA square. Okay. Yes, it's correct. So for r equal to a, it's non-zero, and it it's also given the integration is over all the space. So that is why it will be the integration will be the function value at x equal to, sorry, r equal to a. So this will be 3a square. Second, it's given to find out the integration r minus b square delta q 5r dv, where v is a cube of side 2 centered at the origin and the vector b is 4 I cap plus 3 z cap. Just use delta q 5r. It will be So in one dimension, it is 1 by k delta x. In three dimension, it will be 1 by kq delta q. Yes, 1 by 5 is correct. 5q delta q r dr. So the value is non-zero at r equal to 0. That is at the origin. Origin is inside the volume V. So it's given the Q is centered at origin. So that is why this will pick up the value at r equal to 0. So we have minus b square by 5q. B square vector b is given. So that is why this is 3 square plus 4 square, which is 5 square by 5q. 1 by 5. Okay, good. Now let us see what will be the integration for this. C4 delta Q R minus C dV, where V is a volume of sphere 6, radius 6 above the origin, and C is given 5xk plus 3ik plus 2jk. So first see whether the point where the delta function is vanishing or it is non-zero, whether it is inside the sphere or not. If yes, then evaluate the integral. If not, just put the value as 0. So for this one, you have to check whether C is inside the volume, inside the sphere of radius 6, which is centered at the origin. So for this, what you need to check whether C is less than or equal to 1 or sorry, less than or equal to the radius or. So the C, it is square root 5 square plus 3 square plus 2 square. This will give 25 plus 9 plus 4, 38. And this 38, it is greater than square root 36, right? Which is 6. So that is why this point is not inside the sphere, it is lying outside the sphere. So that is why the integration is 0. Okay, so this will be our last Dirac delta function. Then we'll move to few more problems on conservative force and Stokes theorem. So D is 1, 2, 3 is 3, 2, 1. And V is a sphere of radius 1.5 centered at 2, 2, 2. Try to evaluate first. So please remember the center is not at the origin. Here the origin is shifted to 2, 2, 2. So you have to check the point according to the origin. Anyone? What will be the answer for this? So you have to check E minus R. It is within the sphere of radius 1.51. So for this, what you can do? So origin at 222. Let us say the point is here. So just see whether this length element is less than or equal to the radius amount. Yes, minus 4 is correct. Okay, so I think then you know how to calculate. Let me briefly go through the process. E minus R, it will be square root 321 minus 222, which is 1 square plus minus 1 square, which is square root 2, and this is less than 1.5, right? This is 1.4. So that is the point is inside the sphere and the integration will give a non-zero value. So you have B R cap D minus half del Q D minus half D. So this will give E dot D minus C. E is given, this is 3 to 1. D is 1 to 3 minus 3 to 1. So this is 3 to 1 dot. This will give minus 2, 0, and 2. The dot product will give minus 4. Okay. Now let us see the next problem we have. This question is about finding out the line integration about a path which has a curved path as well as a linear path. Okay. So volume V is, sorry, the function V is given. It is R cos square theta R cap minus R cos theta sin theta theta cap plus 3R phi cap. So let us define the path. This is path 1, path 2, path 3, 4. For path 1, what we have, R is changing from 0 to 1, right? So theta is constant, theta is pi by 2, and phi is also constant, which is 0. So length element will have only the R component, that is dr r cap. It won't have any theta and phi component. So the integration now is V dl. So r cap part is r cos square theta. So this is r cos square theta dr, and theta value is pi by 2. You can see it here, cos pi by 2 is 0. So this integration is 0 for path 1. Let us see for part 2. For path 2, you can see theta is changing, sorry, phi is changing, theta is constant, and r is constant. So we have r is 1, theta is changing from theta is pi by 2. So d theta should be 0, dr is should be 0. And phi is changing from 0 to pi by 2. So dl will be in the phi cap direction. And in phi cap direction, the length element we have is spherical coordinate. We have r sine theta d phi cap. Theta is pi by 2, so this will give r d phi cap. So now we have v dl, which is for phi cap we have 3r, so 3r square d phi. R is 1, so we can cancel this. Phi is changing from 0 to pi by 2. So this will give 3 pi by 2 for part 2. For part 3, for this straight line path, this will have um, here both theta is changing as well as the r is also changing. So that is why phi is constant, it is pi by 2. So d phi is 0. But the value of theta, it is changing from when theta is here, it is pi by 2. Remember that theta is the angle between this with the vector this r vector. So don't take this angle. Okay. So theta is changing from pi by 2 to a point, this point, which is length is given 0, 1, 0, 0, 1, 2. So the theta value is tan inverse half, right? So dl, it will have both dr as well as the theta component, which is r d theta cap. R you can see also r is changing from here, it is value of r is 1, and for this one it is square root 1 square plus 2 square, it will give root 5. So v dl should be r cos square theta dr minus r square cos theta sin theta d theta. You can see it here both because the r and theta is also changing. You need to express the integration only in terms of one variable. Otherwise, you won't be able to calculate what will be the integration. So that is why either you have to express r in terms of theta or theta in terms of r. Both are equivalent to each other. To find out the relation, you can see for this path, this value, which is r sine theta, this is 1. This is 1. So r sine theta is 1. R is 1 by sine theta. So dr will be minus 1 by sine square theta cos theta d theta. So you need to substitute this with the integration. Okay. So v dl, it will be 1 by sine theta cos square theta cos theta d theta minus r square, which is 1 by sine square theta cos theta, sin theta, d theta. So I'm leaving the integration to you to calculate. You know the limit for theta, right? Theta is from pi by 2 to tan inverse half. Just simplify this equation. You will get the line integration will come out as 2. Check this. If you are not getting this, then let me know. I will show the steps in the next tutorial. Okay. So this is for path um, 3. For path 4, the R changing, theta is constant and phi is constant. So finding the integration is easy now. So for path 4, theta is constant. It is at tan inverse half. Phi is constant. It is pi by 2. And R is, so this says d theta is 0, d phi is 0. So R is changing from root 5 to 0. So that means dl is dr r. So v dl. This is r cos square theta dr at theta tan inverse half. From theta tan inverse half, you can calculate what will be the cos theta value. So this will come around 2 by root 5 square dr, and this is root 5 to 0. Integration will give 2 minus 2. So to total line integration, it will give minus 2, 0 plus 3 pi by 2, no, 3 pi by 2 plus 2. So 3 pi by 2. Okay. Okay. So the next one is based on the Dirac delta function, which is quite easy. It, it can take hardly 1 minute to find out the answer. So let me know, solve it. Let me know the answer for this. Given the function j, which is volume eta minus r del rk by r square dv. What will be the integration value? Yes, it's correct. 4 pi. You know that this is 4 pi del q. The sphere is centered at origin. That means 0 point is there in the limit. So it will give 4 pi e to the power minus 0, which is 4 pi. Okay. Let us see a problem on conservative fields. Sorry, conservative field. So you have two vector fields. One is F1 is y square z cap, and F2 is x cap plus y cap plus z cap. So it is asking you to find out what will be the divergence and curl of each vector field, and which one of the following can be written as a gradient of a scalar and which can be written as a curl of a vector. Find the scalar and vector potential. Finding the divergence and the curl. It's easy, right? It's Cartesian coordinate. So divergence F is rho by dou z y square, which is 0. Curl of F1. So this will give I cap, j cap, a cap, dou x, dou y, dou z, 0, 0, y. So this will give dou y x. For F2, we have F2, which is x x cap, y cap, z cap. So divergence of F2, this will give 3, right? And curl F2, this will give 0. You can see it here for F1, the divergence of F1 is 0. And you know the divergence of curl is 0, right? So that means you can write F1 as a curl of some vector potential, let's say A. So this is saying you can write F1 as a curl of some vector potential A. And for F2, curl of F2 is 0. And we know that the curl of gradient is 0. So that means F2, you can write it as gradient of some scalar. And let us say this is divergence of V. So we have calculated divergence, curl, and we have already answered which one of the following can be written as gradient of some scalar and curl of vector. Now we have to find out what will be the vector potential in the scalar potential. So for this, F1 is, we have taken it is curl of some vector potential A. So F1 we know it is y square z cap. And curl of A we can find out using the, so if you find out this, if you write the total expression, this will be dou z by dou y minus dou y by dou z x cap plus dou x by dou z dou az by dou x y cap plus dou ay by dou x minus dou a x by dou z cap. In the right hand side, we have only z cap components. So that means this is 0, this is 0. Only this component will be a non-zero value, which is y square. So vector potential, if you remember the lecture, it's not unique. It can have various forms. So that is why it's not like you will, for this vector field, you will have only one kind of vector potential. It can have different kind of expression. So if we look at this, what will be the easiest vector potential that you can guess? It is giving y square. So if we say that A is y square x, y cap. So for this will be a y square value, and this part is zero because it doesn't have any x component. So this is the one of the simplest vector potential that you can guess. Okay, so this is for the vector potential. Scalar potential, you can follow the same process. You know F, you need to find out what is V. F2 is given, so this is x cap plus y cap plus z cap, which is minus x cap dou v by dou x minus y cap dou v by dou y minus z cap dou v by dou z. So dou v by dou x is minus x, dou v by dou y is minus y, dou v by dou z is minus z. So you can guess it here. The value vxy, you can take x square plus y square plus z square by 2, right? So this is how you can calculate it. Let me clarify your doubts first. I think it will be better uh, for me to clarify the doubt first, then we'll see the next questions. Uh, I think one of you have asked doubts during the initial live section. One of you, I think you got confused while calculating this. I think this one. Vector and scalar potential formulas. Mm, okay. You mean this? Negative sign, it's like a convention. So it's like if you recall the electric field and the vector electric potential. So the electric field is it's along the direction of higher potential to lower potential. So that is why we have taken a negative sign here. So it is a convention. It's not like a hard answer. Any other doubt? Okay, one of you is unable to write it in the chat box. Someshwar, I think. Uh, can you ask your doubt now? I have unmuted you, so you can ask your doubt.
Hello, madam.
Yes. Hi.
Okay, so while I was attempting for answering assignments,
Okay.
few answers I found the options are not available. Like in assignment one,
Okay.
there is a volume calculation for a hemispherical shell.
Yes.
I think the options are not available. The correct answer would be different than the answer given.
Okay.
So
So if
in
so,
such
I
cases,
think you have raised the question in the discussion group also. Uh,
yes.
uh, Let us give some time because they will recheck it and they will if if whatever you are saying is correct, then That question I will get a marks for that. Okay.
Okay. If the similar thing happens when the actual exam comes, what are the rules for
No,
this
no.
kind of question?
It won't happen because actually exam there will be lot of reevaluation and lot of checking. So maybe it's a small mistake for now, but it won't be there in the actual exam. There will
Another
be
point is
verification, lot of verification to examine the questions, answers, cross verification. So I think
okay.
you won't face this kind of problem in the exam.
Okay, madam.
Mm.
Other thing is that the assignment number three is exactly same to the assignment number two. I think.
Yes, yes, yes. I saw that.
Okay.
So they will change the assignment. So they will float the new
Okay.
assignment. Mm.
Okay. Okay, madam. Thank you. That's all.
Okay, anyone? 1 by 4 pi integral with respect to dv. Uh, so you are talking about question number 7, I think, or 1 by 4 pi integration. It's not there. Can you let me know the question number? This one, you think? 1 by 4 pi integration. This calculation from the actual formula of scalar and vector potential. Mm, okay, so you are talking about, I think, the lecture. In the lecture, they have given one formula for finding the vector potential and the scalar potential. Okay, so I think it's similar to, let me write the formula. Please give me 1 minute. Where is it? So currently, I think I have to check whether the expression is correct or not. Mm, I think it was. So let me check once. Mm, I think you were asking about this in other dog where D and C are known for us. Okay. You can use this formulation also, but you can say this, you can easily guess it from here. No need to take the integration, right? So that is why I've just you can follow these steps, or you can use D of R is given, then you can find out what is F of R. But let's keep it for the case where it's the function is really complicated, so you can't guess it. So in that case, you just use this formulation. But if it is easy, like you can easily guess, then try to use this process. Just compare component wise, then find out the formula for this. Okay, if no other doubts is there, then let me go to the next problem. Can anyone check whether this field is a conservative or not? So to check it, what is the what is the thing you need to do? So you need to check whether the call of E is zero or not. Because if you recall the Stokes formula, Stokes theorem, the curl is related to the line integration. So if the curl is zero, the line integration will be zero. So that means the whatever path you choose, the it will give a zero value. So that means, and also when the curl is zero, you can write it in terms of some gradient of some scalar. So for that case, also we say that field when we write E as a some gradient of some scalar, that field is a conservative field. So conservative force has lot of definition. You need to remember uh, all the conditions like curl is zero, the line integration, the closed line integration is zero, and you can write E is some gradient of some scale. So these are the definition for checking whether the function is whether the vector is a uh, conservative force or not. So call of field. So it's in the Cartesian coordinate. You can easily find out it. Dou x, dou y, dou z. 12 x square minus y square minus 2xy 0. Check it, it will give a value of 0. Okay. And this is 0 means you can write it in terms of some scalar, gradient of some scalar. So the steps we followed before, use the similar steps to find out what is the vector potential. Let me give you the answer. V of xy, you will get it as xy squared minus 4x cubed plus some constant. Check it. Okay. Okay, this is all about today's live session. I think we covered a lot of problems. Most of the problems are from Griffith because I think it's better to go through the problems in Griffith also. And some of the problems are from few textbooks. I think okay. So let me see whether you have any doubts in any of the problems. Otherwise, we'll end our live session for today's, and we'll see next few problems in next Friday. Do you have any query for problems that I've solved today? Try to solve the problems related to divergence, Stokes theorem, and as well as line integration. Okay, so for that case, what you can say, you will see various steps like how you can find out what will be the area element for this kind of surface. So if you do it, then it will be easier for you in the exam. In assignment one, eighth problem was not correct. They've asked for unit vector, but options are all scalar. Okay. Assignment one, question number 8. So have you asked the query in the discussion forum? Because if you ask it only when it will be the query will be resolved. So it's better to ask in the discussion forum. Okay. Try to use the discussion forum to ask your doubts. And during the live section, you can ask the doubt related to the problems that I am solving. But for assignment that is floated in the NPTEL site, it will take some time because they will re-verify it, they will recheck it, then uh, uh, solve your query. Okay, so I would suggest use the discussion forum to ask your doubts. You have doubt in a question of assignment one in eighth problem, write it in the discussion forum. They will answer your query. Okay. Okay. Okay, so thank you for joining the section. I hope the problems that I've solved it is useful and it will help you to you know, clarify the concept. Okay, let us meet on next Friday from same time from 6 to 8, and we'll solve few more problems. For now, let us end our session. So thank you for joining the section. Goodbye, everyone.